All right, everyone. So this topic here is probably my favorite topic when it comes to physics because there's just a whole lot that goes into gravity, and a lot of us think we understand gravity, but hopefully as you watch this presentation, you're going to learn there's a whole lot more to it than what you previously thought. So there's really three main categories that we're going to go over today. It is a longer video, and there's a lot that I'm going to go over. So please take your time and rewind if you need to. And I highly recommend with this topic using some of the supplementary videos that I've provided for you, because as much as this video is going to give you the facts and what you need, those videos do a really good job of capturing some things that I am unable to capture. So the three things we're going to talk about are what affects gravity, in the sense of what makes something have a lot of gravity or a little bit amount of gravity. We're going to talk a little bit about falling objects and what happens to them, and then also something called center of gravity. So before I even start though, I do want to show you the videos, and just because if I show it to you in the beginning, you'll know what's what and maybe where to go in case you need help later on. So this first video here, to me, is the absolute best video. It just gives you a good overview, kind of like I'm going to do. And these two topics here talk about terminal velocity, which I think is probably the hardest thing to get in gravity, so I highly recommend taking a look at them. This is, I think, the better one, and this is a little bit more complex look at it, but still a good one. And then these two here are really good because it shows you falling objects. This shows you hammer and feather that fell on the moon when the astronauts went there, and this is a really recent video of kind of them duplicating a similar thing here on Earth. This one I skipped over shows the videos that kind of answers the question of when you shoot a gun and drop a bullet, what hits at the same time. And then this talks about center of gravity, which we're going to talk about. And this I think is a good video. It kind of also shows some difficulties people have, but answers some of your questions. And I believe those are the main videos that I am providing for you, and there might be more, and there might be less by the time you actually watch this video. All right, let's get on with it. So the first thing that we're going to talk about is what actually affects gravity. So for this, we're going to use this little demonstration here. So this kind of represents one object, this represents another. So this could be you, and this could represent the Earth or any other planet. So there's two main things that affect gravity, because we know gravity here on Earth is different than it is on the Moon, and different than it is on Jupiter and Saturn, and there's got to be a reason why. So the two main things that affect gravity are mass and distance. So if we take a look at this, the general rule of thumb is the larger the mass of an object, the more and more gravity it's going to have. So go to Jupiter that has a tremendous amount more mass, it's going to have more gravity. That's why you'd weigh more on there. So when I say weigh more, hopefully you know that I just mean the force of gravity on you. That's all weight is the force of gravity on you. So when you go to a place with more mass, there'll be more gravity on you. But the second thing that affects it, besides simply mass, is distance. The closer two objects get, you see the arrows up here, the more and more the force of gravity is on them. So I always think of gravity like a magnet. It's not the exact same force as a magnet, but the properties are the same, in the sense of a really, really big magnet will have a very strong pull towards it. And the farther you are away from the magnet, the less you're going to feel of that force. It's the same thing with gravity. That's why astronauts, as they get farther and farther and farther away from the Earth, and eventually end up in space, well, then they're kind of floating around doing nothing, I guess, because there is no gravity, because they're so far away from Earth. And the closer and closer you get to Earth or any other planet, the more that pull kind of pulls you in. So the more mass you have, the more gravity you have, and the closer you are together, the more gravity you have. So I just want to go over a couple little examples here to make sure that we get this. So let's just say that here are two planets, exactly the same size, but this one happens to be more mass, more dense, it's more mass. This one would have a stronger gravity on it. Even though they're the same size, because it has more mass, this would have a stronger pull of gravity. And on the flip side here, let's say these are two different planets that have the exact same mass. This planet would have less gravity than this one. And the reason for that is because I said it has to do with distance, and it has to do with distance from the center. So from here on the surface of the planet where you'd stand to the center, compared to here on the surface of this planet where you'd stand compared to the center, this would be a farther distance. So you'd be farther away from the center spot. So that's the deal with gravity. It has to do with how far you away from the center. And that's why when you climb a mountain here on Earth, even though you're not a lot farther, let's just say you climb this little mountain here, you are a little bit farther from the center of the Earth. So technically, at the top of the mountain, you would actually weigh less because you're farther away from the center of the Earth. That's how that works. So there actually is a mathematical formula to gravity. We don't do a whole lot with the math, but maybe if you look at the formula, it'll make a little bit more sense. So the force of gravity, the formula is G times m1 times m2 over r squared. Okay, so it sounds complicated. So G is called gravitational constant. We're not going to worry about that because it really doesn't come into play with understanding gravity, just figuring out the number. So really this is saying the mass of two objects, so the mass of you and the mass of Jupiter, if you're standing on Jupiter, all divided by r squared, how far you are away from the center. So those are the two things that affect it. If we take a look over here at some real planets as opposed to my fake planets, maybe it'll make more sense. So here it gives you the radius of the planet, the mass of the planet, and then the gravity of the planet. So it kind of does the math for you. So here we are on Earth. 1 times g, g is essentially the gravity here on Earth. So you can kind of use that as a basis for comparison. So here's the mass, here's the radius. If you look at the moon, okay, the moon has way less gravity, and the main reason for that is it has way less mass. And even though the radius is smaller, so that should make the gravity a little bit more, it's not, because the mass is so small. So let's look at some interesting situations here. So we have Jupiter, which has more than twice the amount of gravity that Earth does because it has so much mass. But here's where things get a little bit tricky. So here's the Earth with a mass of 5.9 times 10 to the 24th. Here is Saturn with a mass of pretty much the same thing times 10 to the 26, so it's 100 times more mass. Yet the gravity is less on Jupiter. And the reason for that is because the radius is so big, because the planet is so much bigger than Earth. When you actually stand on the surface of Saturn, if you could do that, you would be farther away from the center. So because you're so far away from the center, it actually makes the gravity a little bit less than Earth, even though it's a lot more massive. So I want to make sure that you get that. So more mass usually means more gravity, unless you're pretty far away from the center. Then it might end up actually being less gravity. That's what I mean. It's kind of crazy and complicated, and how do you really know? And that's why that formula was made, so you really could plug in some numbers and figure it out if you had to. And we're going to end this section of our video with the fact that everything on Earth has gravity. And this is probably the hardest thing to really realize. It's easy to say that planets have gravity, but it's important that you know that no matter how small the object is, you just go smaller and smaller and smaller and smaller and smaller, and the force of gravity gets less and less and less, but every single thing has gravity. Everything that has mass. That means you have gravity. That means your dog has gravity. It means the person sitting next to you has gravity. It means that right now you and the person sitting next to you are actually pulling yourself towards each other with a very, very, very small amount of gravity. You don't feel it because it is such a small amount, and the force of friction is so much more than the force of gravity keeping you in place. But every little thing has gravity.